All right, this is a pre-video for section 4.5, just to kind of get us started before next time. So things that are in this section, I didn't really make a pre-class note since I knew we'd be covering a lot of this together, is to determine domain, asymptotes, holes, and intercepts of a rational function, and to sketch the rational function. So I just want to walk you through the different things that we can figure out about a rational function just by looking at the equation in its factored form. So things that we can find out. Okay, so some things that we can do when we have our function factored and we're kind of looking at it is that we can determine the domain by focusing on the denominator. So notice like here, 1 over x minus 2, we know that we can't plug in any positive 2's for our domain. And here we could factor that into x plus 3 and x minus 3 in the denominator. It's for that second one so that we know we can't plug in plus or minus 3. This one, though, is x squared plus 4, the third one right there. And that means that you can never factor that. That's imaginary solutions if you tried to solve it. So there's no, if you square something and add 4, it's never going to go to 0. So there's no domain restrictions there. Now, other things that we want to look at and things that are kind of important are things called asymptotes. So when you talk about an asymptote, it is a value, specifically a vertical asymptote, where you cannot cross that situation. So if your denominator ever equals 0, you're going to get this kind of thing where you have some behaviors where your graph kind of goes up towards that dotted line or down towards it, and it never actually crosses it. So it's going to the infinities. So you may never, ever, ever cross a vertical asymptote. It is like a still wall. We're going to find out that there's two other types of asymptotes, horizontal and oblique. And because they don't really have anything to do with dividing by 0, sometimes they can be crossed. But vertical asymptotes are absolutely a boundary that you cannot cross. Now, the way we find our vertical asymptote is you would factor your whole problem, top and bottom of your fraction, and reduce it down. Anything that's still in the denominator after reducing is a vertical asymptote. If you have a horizontal asymptote, that means you have a horizontal line that is kind of a boundary where you go towards the infinities around it. But again, you may or may not cross it, and we'll show you how to determine that in class. So that's kind of an interesting discussion, but this is kind of what they can look like. And the way you find horizontal asymptotes and oblique, which is the next kind, is you use long division, or you can use a shortcut rule that we'll talk about as well. I usually save the shortcut for discussion in class, but we'll talk about how it's really based off long division. The oblique or slanted asymptotes, that is the, well, they can be anything, but one of the ones we're going to be looking at are y equals mx plus b. But you can have quadratic asymptotes that are oblique. So this has to do again with long division. That's where that comes in. So this is a picture of an oblique that is a line. Okay, so we said if you want to find the domain, you have to have everything factored, and anything that makes you divide by 0, we need to exclude from our domain. To find your vertical asymptotes, you factor both your numerator and your denominator, and you look for factors that cancel. After reducing, any values that are still in the denominator that make it equal 0 are vertical asymptotes. And those would be equations. It would be like x equals that number. To find horizontal or oblique asymptotes, you have to look at the top degree and the bottom degree, and you're kind of really just doing long division. But if you just look at those leading coefficients, the top and bottom degree, then we can talk about how if, say you have, let's write this down. Say you have something like this, x squared plus 1 over x to the third minus 1. X to the third cannot divide into x squared. So that goes in 0 times because cubed can't go into squared. So notice if the degree of the, if n is the degree of the top and m is the degree of the bottom, so this is a 2 for n and a 3 for m, if your top degree is smaller, so this is top degree is smaller, just to write that out a little bit better, then you go 0 times when you do long division. So you have a horizontal asymptote at y equals 0. So that's interesting. It's just that quotient up top. If your degrees match each other, so this is like case 1, here's case 2. If your degrees match each other, see how these are both x to the second, then what happens is you're going to put let's make this top one a 4 just so it's a little bit easier to do the division. But 2x squared minus 1 into 4x squared plus 1, you'd say how many times does 2x squared go into 4x squared? And the answer is just 2, no variables up top. So that means that that long division is telling us that it's still a horizontal asymptote, but it occurs at the leading coefficients on those degrees, because 4 divided by 2 is 2. So whatever your leading coefficients are, if your degrees are the same, that as a fraction is your horizontal asymptote. And again, we're going to do tons of these in class, so we're just kind of giving you an introduction. And then the last possibility is if the degree on top is bigger, and we're specifically only looking at ones that are bigger by 1 degree. So let's say you had x squared plus 1 in the bottom and 2x to the third minus 1 on top. When you go to do the long division here, you're going to notice that you get an x on top. This is the first time you get an x on top, because x squared goes into 2x cubed 2x times. We would finish this out, so we do subtract 2x cubed, subtract 2x. That means that we're really doing negative 2x minus 1, and or excuse 2x squared, I should say. We missed our x squared term. No, we didn't. This doesn't divide any further, so that would just be, our b would be a 0. So in other words, this is going to be like y equals mx plus b, which would be plus 0 here. So again, I'm not too worried about actually showing you all of the long division in gory detail right now. We just want you to understand that that's what's going on here. So you cannot have horizontal and obliques at the same time. You either have a horizontal asymptote or you have an oblique because of the long division, and it's based off of when is the degree on top bigger, the same, or smaller. So case 3 is the case where the top is bigger, so that means you get an oblique. Case 2 and 1, you get horizontal asymptotes, and if the top is smaller, it's 0. If the top is the same as the bottom, it's going to be a ratio of those two coefficients. So again, like I said, we're going to do like 7 or 8 graphing examples on our class. So I feel like you'll see a lot more of that then, but that's kind of how we find those. Another thing that's different is, remember we said you reduce your rational function before you find your vertical asymptotes. If you have a function and they have a common factor, that means you have something called a whole. So factors that cancel out calls wholes. And wholes are ordered pairs. So we'll talk about that in a minute, but something to note, that means this guy right here is a vertical asymptote because it doesn't cancel out. And another interesting thing, anything on top that still has an x is actually an x-intercept. We'll need to know that for later, but so anything that cancels out is a whole. Anything that's still on the bottom is a vertical asymptote. Anything that's still on top with an x is an x-intercept. So if you want to find your whole, you have to figure out what made this part that canceled out equal 0, which in this case would have been a negative 3. You plug that negative 3 into what would be left, which would be x minus 1 over x minus 7, and work that out, and that gives you the other part of that ordered pair. So negative 3 comma 2/5 would be an open circle there. That's a whole. And then like we said, after you've reduced the top, anything left on top, you set equal to 0 to find your x-intercepts. Y-intercepts, you plug in 0 for all of your values. So we're going to talk about these graphing steps next time in class together. I just want you to do one problem with me on the pre-video, and that is we're going to look at this specific example, and we're going to just find as many things as we can out about it. I know they only asked for the asymptotes and the wholes, but I'm going to write down everything I know so we can just see that process. So let's first of all look and see it's completely factored, and there is something that cancels out, so that means we're going to have a whole at that value. We have an x in the bottom still, so we're definitely going to have a vertical asymptote. We have an x on top, which means we're still going to have an x-intercept. So let's talk about what we know. So our vertical asymptote, when you write this, it should be x equals, it's an equation, and it's whatever this would be if you solved it. So x minus 1, you'd add 1 over to the other side. So x equals 1 is my vertical asymptote. My horizontal or oblique asymptote, because remember you can't have both at the same time. Let's look at this part that's left over. This would be 2x plus 8 if I distribute that over 5x minus 5. So notice the degree on the top and the degree on the bottom are exactly the same. That means if your top and bottom degree are exactly the same, it's a horizontal asymptote and not an oblique. So this would be none. And then it's just this ratio of these two values. And remember, horizontal and oblique are always y equals. So this would be y equals 2/5. So we have no oblique, but we do have a horizontal. We can go ahead and figure out this x-intercept. It's whatever would make that top right there equal 0, which would be a -4. Remember, x-intercepts are written as ordered pairs. If you want to figure out your y-intercept, plug in 0 for this part right here, the part that was reduced down. So that'd be 2 times 0 plus 8 over 5 times 0 minus 5. That's going to be 8 over -5. So 0, comma, -8/5. And then it did ask us for the whole, so we want to go ahead and write that. So what you do to take the whole is you say, okay, what part would have made that part that cancels equal 0? And that would be a -2. You plug -2 into what's left. So 2 times -2 plus 8 over 5 times -2 minus 5. That's -4 plus 8 over -10 minus 5. That is 4 over -15. So -4/15. And we found all of this out, all of these pieces of information. We never did anything like a table of values. It was all based off of understanding which pieces mean certain things and knowing how to, factor, which it was already pre-factored for us. But all this can be done just by looking at the equation. So I think that's really fascinating. And that's really the end of the pre-video. I don't want to do too much on this video and overwhelm you. So what we'll do on our class is that we'll take up from this point and we'll show you how you can use all this information then to sketch some graphs. And I will see you guys in class.